All right, Math 6, Accelerated Students, Chapter 14, Section 4, Solving Proportions. This is such an important section. I probably always say that, but most of the sections are indeed important. Essential question, how do I solve proportions vertically, horizontally, and using cross products? So there are going to be 3 different methods that you need to be able to use by the end of this lesson to solve a proportion. Well, lest we forget what a proportion is. A proportion, equal fractions. It's anything in the form A over B is equal to C over D, and of course you can have as many fractions as you want that are equal, but that means that they're really equations, and if we're solving, we're finding the value for one of these 4 different parts of the proportion is going to be a variable we're going to have to solve for it. So first, how can I use a table to solve a proportion? Ali burns 100 calories for every 15 minutes he swims. How many calories will Ali burn in 1 hour? Hopefully you see there are how many units here? Calories and minutes. And so what we're going to do is make a table where we have calories in the top, I was going to say numerator, calories, and then I have minutes in the denominator. I think we've discussed this. Time is usually in the denominator or the bottom. 100 calories in 15 minutes. And we want to know how many calories will Ali burn in 1 hour. Wait a second. Minutes, hours. What's the conversion? How many minutes in 1 hour? 60. So we don't want 15 minutes. We want 60 minutes, which is an hour. And we're going to have to get the number of calories that are burned in that 1 hour. This is the mystery number. So these are really equal fractions. I could write this as an equation, but instead, we're just going to go from 15 to 60. How do I get from 15 to 60? Sometimes you need a stepping stone. Sometimes you can, I think we did a unit rates. We usually had 1 here. So divide by 15 times 60. And then you do here, divide by 15 times 60. But we can circumvent that and just go straight to 60 by multiplying by 4. And then we can do the exact same thing with 100, and we get 400 calories in 1 hour. So 400 calories in 1 hour. Pretty easy. It's the same as finding the unit rate, isn't it? Well, sorry, if you're talking about hours. But yes, in terms of minutes, it's finding a denominator of 60. Okay. Anyways, I think you get that. That's not a big deal. It's something you've done so many times before that I'm pretty sure you've got that down. So we'll just go on to the next example. Keep on blowing through. How can I use a double number line to solve a proportion? Well, using the same example we were just on, where we had calories and we have minutes, instead of using a table, we can use something called a double number line. That means you have 2 number lines that are stacked on top of each other. And what we do is we make an association between calories and minutes, the one that we're given. So for instance, in this one, we had 100 calories in 15 minutes. Down the number line, you're going to have a place where you have 60 minutes, right? And so it's the same kind of idea. How do I get from 15 to 60? You multiply by 4. How do I get from 100 to the mystery number? You multiply by 4, you get 400. So 400 calories in 60 minutes, or 400 calories in 1 hour. Same thing with a graph. You could use the graph, as you can see. Well, how can I use a graph to solve proportion? We have time on the x-axis, calories on the y-axis. If you have 100 calories in 15 minutes, well, here's 10 minutes. 15 minutes is here. 100 calories in 15 minutes. We want to know how many calories in 60 minutes. Well, this is a proportional relationship. Whether you know what that means or not, it doesn't matter. We have a proportion that's going on, and so it's going to create a line that's going to pass through 0, 0. And so if you continue to put this line out, and it looks like I'm going up to right 3, up to right 3, and up to right 3, and one more up to right 3. Okay, we make that line. All of those are going to be proportional. This is the one we care about because at 60 minutes, we're at 400 calories. So once again, we get 400 calories in 60 minutes or 400 calories in 1 hour. Okay, that's to kind of visualize what was going on. We were going to use these in a activity, but here's how you just do it algebraically using the tools, the properties of equality that we've learned before. Okay, here we go. So going back to the essential question, how can I solve a proportion horizontally, vertically, and using cross multiplication or cross products? Okay, how can I solve a proportion horizontally? First, if we're solving, we're finding the value of the variable that makes the equation true. So how am I going to do this horizontally? What you're going to do is you're going to think of these as just fractions. How do I get from 5 to 20? I multiply by 4. So what do you think you have to multiply 4 by? 4. So what's r equal to? R equals 16. So that's solving horizontally. You've solved the proportion because you found the value, 16, of the variable r that makes this equation true. Now, it won't always work. So that's why I'm going to give you this other method, which is vertical. See, for instance, if you're asked to solve this one, how do you get from 9 to m? Well, let's find out. How do we get from 3 to 4? There's no good way. You can do it. It's 3 times 4/3 will get you to 4. But instead of doing horizontal in this case, because it's just, fractions, and fractions scare me. Instead, we can go vertical. How do I get from 3 to 9? And the answer is multiplying by 3. So then what do you think you have to multiply 4 by here? 3. And what do you get for m? 12. So if horizontal doesn't work, which is kind of like using a ratio table, right? Or a double number line, then you can try vertical. Okay? But what about this next one? This is a little weird. So how can I solve a proportion using cross multiplication? And really, we should call that cross products. I don't like that multiplication's written there. I don't know why it's written there. Let's call it cross product, but yeah, it doesn't matter. Here's the thing. That cross product name, you've got to be careful with these. Whenever you see these names, cross products, people start using them when they shouldn't. Here's what's really going on. This is an equation. If we want to solve, we can use any of the properties of equality. What's the property of equality? Whatever operation you do with a number to one side of the equation, you have to do it to both sides to maintain equality. So in this case, what we're going to do is we're going to multiply both sides of this equation. We're solving for x. We're going to multiply both sides by 9, and we're going to multiply both sides by 12. Okay? I'm going to show you how, when you do that, this is what happens. I'm going to show you the easy way first. You cross multiply, or you find cross products. What's a cross from 12? 6. So what's 12 times 6? 72. Equals. What's 9 across from 9 is 2x. What's 9 times 2x? 18x. Use multiply. 12 times 6, 72. 9 times 2x, 18x. Now I'm solving for x. 18 is multiplying x. How do I get x by itself? Because I'm solving for x. I divide both sides by 18. Remember, we use fraction bar anytime we're using the division property of equality. 18 divided by 18 is 1, leaving you just 1x. I don't need to write that 1 in front of here. That coefficient of 1's there if you don't write it. Or if there is no other number in front of x, no other coefficient. 72 divided by 18 is 4. So we have solved the proportion. We've solved for x. Okay, let's see what's actually going on there. For students who are actually interested in seeing what's happening, here's what actually happened. I multiplied both sides of this equation by 9. I did. So 9 over 1, I guess. 9 over 1. Okay, these 9s cross-canceled. Okay, they cross-canceled, leaving you just the 6. But look over here. When you multiply by 9 over 1, what is that 9 multiplying? 2x. That becomes 18x over 12. So let's think about what happened. The 9 down here cross-canceled. It kind of went up here and multiplied the 2x. So 9 times 2x is the 18x. Now, if I take this new equation, let's put the 6 over 1, and I multiply both sides by 12 over 1, these 12s cross cancel, leaving you just the 18x equals, and then over here it's 12 times 6. Hey, that's what we did before. 12 times 6 is 72. So cross products or cross multiplication is the same as using the multiplication of property of equality with both denominators in the fractions, in these ratios when they're equal as a proportion. So what I would do anytime I'm solving a proportion is I first look to see if I can do it horizontally, then I look to see if I can do it vertically, and then I see if I can use cross products. Cross products work every single time because it's really just the properties of equality, but these horizontal and vertical methods can be pretty quick. Just to show you in this one, 6 over 9 equals 2x over 12. There was no good way to get from 9 to 12, and there was no good way to get from 6 to 9. If you had reduced 6 over 9 to 2/3, and because 6 over 9 and 2/3 are the same thing, I could just replace 6/9 with 2/3. Now you can go horizontally. From 3 to 12, you multiply by 4. And from 2 to 2x, you multiply by 4, which means 2 times 4 is equal to 2x, right? And so if you do 2 times x equals, or sorry, 2 times 4, I apologize. Let me get that right. Whoops, I was on the wrong side of the equation. Oh no, and now this is gonna fail. I think it is. Oh no, is it gonna work? Slowly. Okay. Sorry, everybody. This is my awesome equipment here. Okay, 2 times 4 is 8 equals 2x. And if you divide both sides by 2, you get 4 equals x, just like you did when we used cross products. So just showing you that it would still work horizontally even if you had a coefficient in front of the x in the proportion. You are all amazing. I hope you're all doing well, and I miss you all so much. Have a good day.